Hello everyone, N3FJZ here. On the SolderSmoke Discord, we have Grant Brown put up his video for his direct conversion receiver, and he observed an interesting phenomenon when he moved his battery from, he had the battery set up where it was feeding the mixer or the oscillator board first, the positive and ground connected to the oscillator board, and then he had the audio amp soldered to the end of the board chain. And when he put the battery on the oscillator side, it would oscillate. The audio amp would oscillate. But then when he moved the battery over to the audio amp side, it would not oscillate. And in this video, I'm going to go through and describe what I think is happening, because I've experienced that many years ago, and this is what I found. All right, here's a simulation on an LT Spice of the 3-stage audio amplifier. And in this simulation, I have the power leads coming from the battery directly to the what I call the driving stage. This could be any stage that drives the audio amp. Here I just got a simple transistor circuit just to simulate some circuit that would drive the audio amp, and it's quiescent, so it's not oscillating, or it's not providing any signal source. It's just sort of there. And I have the 9-volt battery positively going down to the top of this stage, and the ground wire going directly to this driving stage. Now these two resistors here you see, they are simulating the ground path. Even though the boards are soldered together through ground braid, there is a minuscule amount of resistance. Here I have it represented by a 0.05 ohm resistor. And same way with the +5. But you'll see the +5 doesn't matter as much as the ground does. Okay, so when I power this circuit up and simulate it, and you'll see this trace on this side, we're getting oscillation on the output side of the audio amp driving the speaker. We're getting oscillation here. This oscillation is approximately 28 hertz. Okay, now if I go back over to the audio amp, and we move the ground connection from the driver stage over to the actual audio amp side, bypassing this resistor. Run a simulation. The oscillations have stopped. See, it's 0 volts. What's happening here is that when the amp starts conducting power when the ground lead is on this side, you have a current flow, and you'll have a voltage drop across the ground. Even though it's very small, there's just enough voltage drop, elevates the ground higher. And with respect to the signal, looks like the signal is changing from the perspective of the transistor base. So as the ground rises, it looks like the signal comes down in value. Or it could go up, I'm not sure which. But what happens is you'll get a feedback, because then when this, it would make the signal look like it's going down because you're rising the ground reference. So that is, when the signal goes down, the current slacks off, the voltage drop changes, and it creates the feedback path. That's my theory. At least that's how I discovered it. And so hopefully that makes it clearer what's going on. The idea is when you build a transceiver of any kind, you want to bring your power from your battery or your power source and make it land first on the heaviest current consuming part of your circuit first. Then you can branch it back to all the other circuits downstream. And you'll notice that if you look at some of the schematics for the commercial receivers, the first stop for the power input is the PA, the power amplifier for the RF. It's the first place that it goes. Then they'll have traces that will send it to all the other parts of the circuit, and the grounds also to the other parts of the circuit. So the idea is that you want your ground, not so much the power, but the ground has to be at your highest consuming current source first. Then you can cascade it back to your other circuits that don't consume as much power. So hopefully that makes sense. Anyway, enjoy, keep building, never stop experimenting. This is N3FJZ73, everyone.